Okay, good morning everyone. My name is Rotem. Really excited to be here in Madrid with you all today. This little guy comes to me to every meetup and every talk, so it's for me, not for you, but you can enjoy looking at him. So a bit about myself. I'm CTO, co-founder of Riga. Part of my job, I am the maintainer of two fairly large open source projects. One of them is called Ant. Ant is a ORM for Go. It's a Linux Foundation backed project that started by my co-founder while he was working at Facebook. And the second one is called Atlas, which you can see from my t-shirt is going to be the topic of our discussion today. So Atlas lets you manage your database schema as code. We open source it something like 2 years ago on GitHub. It's used by many companies in the industry. And it has been sometimes called by people in our community a Terraform, but for databases. So I hope by the end of the talk, you'll understand the reason why. So our agenda for today, we're going to discuss briefly how do database schema migrations work, how do people manage their databases today. We're going to discuss the declarative model for managing resources. And we're going to raise the question, should we apply the declarative model to managing your database? Finally, we'll discuss something I called avoiding toll roads, and we'll get to that in a few moments. So let's start by presenting our hero, our protagonist, which is your database. So a few fun facts. Every application has one, or almost every application has one. Your database contains the application state. So your application is usually a binary or a Docker container that is stateless. It is replaced when you scale up or down and when you change versions, but not your database. Your database is the stateful component that maintains your application state. Your database always has a schema. This is always true for SQL databases, but debatable for other kinds. We're just focusing in this talk on relational databases. And this schema reflects your application data model. So if you are building an e-commerce system, your data model consists of products and categories and inventory and invoices. Okay, and if you're building a different application, then and this schema is reflected in the database structure. Number 4, as your application evolves, you respond to market demands, you add new features, you refine your model of the world. Your database schema must evolve as well. And finally, and I think it may not be a secret to you guys, if you mess up changing your database, you are in big trouble. Database outages, database-related outages are notoriously the least fun in the whole universe to debug and manage, because contrary to many components in your system that are stateless, you can replace them with others. You can replace your database with a new one, but it will come back without your precious data. So your CEO will not be very pleased. When Ariel and I started working on Atlas 2 years ago, we noticed this gap, a disconnect even between what we had in the state-of-the-art of managing cloud resources with infrastructure as code tools and whatever was available for managing database schemas. So we're going a bit into this gap to understand it better. If you research this topic, you probably ran into this article published by ThoughtWorks at 2016. It kind of summarizes the current state of the art of what most organizations do to manage database schema changes and how to integrate them with modern automation, modern deployment processes. It's a long piece. I'm going to focus just on one part, which is how the mechanics of how to change your database schema. So this is the point I want to focus on. The article says all database changes are migrations. Okay, so we create a script, a SQL script with some SQL commands, how to upgrade the database, to migrate the database to the next version. The important thing this article says is that we manage this change in source control. So we're not managing our database in some GUI software on the side or running some manual commands to change it. We are looking at these changes as part of the application, and we are putting them in our Git repo. But documenting these changes is not enough, right? We want to integrate it into our automation pipeline, which means we need 3 more things. 1, each migration needs a unique identification, a version number. 2, we need to track on the target database which migrations have already run, so we don't run the same migration twice. And number 3, we need to manage the order. With databases, the order really matters, right? You cannot create an index on a column that does not yet exist. So migration tools need to handle these 3 things. And there are hundreds, literally hundreds of tools for managing database schemas today. Some of them come with your ORM. Some of them are standalone tools and language agnostic like Atlas. And the workflow in all of them, with minor differences, works like this. So as a developer, you maintain in your Git repo a migration directory. This contains scripts, SQL script. These scripts have a version. The version is most commonly the timestamp in which the file was created to maintain a atomically increasing series. This directory is managed and read by a migration tool. The tool, when it is time to deploy to production, it looks in a metadata table, commonly called the changelog table, on the production database to see what migrations have already been executed. And if there is any work to do, it will update the target database. Last but not least, after the tool has run, it will re-update the changelog table to make sure that if we executed something, it will not be reapplied again in the future. So I mentioned a few slides ago this gap. Okay, these tools that probably many of you have been using have been in the market since at least 2004, 2006. Okay, so almost 20 years. And in this time, the DevOps culture and industry in our profession was created. So things have evolved a lot. And when you try to think about it, the gap really boils down to one fundamental difference. And it's a different paradigm. Common migration tools use what we call the imperative model, which means that we provide our tools with pre-computed plans, these migration scripts, and the tool responsibility is to execute them. If you read the documentation for most of these tools, they will actually state, we treat migrations as opaque blobs. We don't know what is the commands that we are running. We're just a pipe to pass commands from the developer or the DBA to the database. On the other hand, modern tools like Terraform and Kubernetes apply a declarative model, which starts with the developer or operator passing the desired state. I want this S3 bucket to exist in my AWS account. The tool has a lot more responsibility. It needs to inspect reality, to connect to our database, to look what's going on there, to calculate a diff, what is the difference between the desired and current state, and then need to formulate an execution plan to turn this into SQL commands or AWS API calls to reconcile between the current and the desired state. Which is better? This is up for discussion. Obviously, like everything in our industry, there are people in both camps, and obviously we built Atlas, so we have an opinion here, but let's try to get a bit deeper into this. So I like to explain things with metaphors. So consider this. We have a friend, and they want to come to our talk today. They are now in Plaza Mayor, and they need to somehow to get to our conference in this lovely university. Raise your hand if you started driving before we had navigation software, like before Waze. Okay, so you will understand this point. So declarative flow is like putting an address in Waze, right? This is my current state. I'm in Plaza Mayor. My desired state is to be in the university. Look at the traffic condition, look at the map, figure it out. This is the declarative flow. But the imperative flow is like when I started driving, my dad would give me a note with these instructions, right? Head north, turn right. After 100 meters, turn left. Okay? So which is better, I ask again. What are some benefits of the declarative model? First of all, if you've navigated in both ways, the declarative model is a lot easier on the mind. You don't need to remember the map. You don't need to remember the commands. You don't need to fit all of this in your head to come up with a plan. Because it's easier, it's also faster, right? Automation, this is the beauty of this profession, right? We teach the computers to do the annoying stuff so we can do more. It also becomes safer, right? This is questionable, but let's say that your automation tool was written by someone who is a domain expert. The tool then codifies this domain expertise. What is the right way to rename a column in SQLite, okay, or to change a type? There are a small stuff that many people are not aware but can have a big impact on how to safely plan changes. And finally, the declarative model is a closed feedback loop, meaning it is connected to reality. It responds to reality. If the traffic conditions have changed, if some road is blocked, a declarative model can calculate around it. But if our plan is pre-computed, we may not even get there, not on time or not at all. So now for the scary part, which is why I need this guy, is a live demo. So how does the declarative flow look like in practice? I didn't think the screens will be so small, so I hope it will come to you okay. If not, the recording will be very nice. But I will try to explain what I'm doing. So what do we have here? In my VS Code, I have here a file called Schema HCL. This is the desired state of the database. It uses something we call the Atlas DDL, Atlas Data Definition Language, very similar to Terraform. If you don't want to learn it, you don't have to. You can just use plain SQL. But we have lots of cool features in this language that are convenient to use, but you don't have to use it. In this top right pane, I have a script running MySQL dump every second to show you the schema of a local MySQL database that I'm running. And here I have just a terminal. I'm going to be showing you some Atlas commands. Okay, so here we are describing a schema named default and a table named T1. We're going to issue our first command, which is schema apply. And we can see that similar to Terraform, the tool connects to the database and suggests to us some plan to reconcile between the current desired state. We apply it, and now the database is updated. As for a developer tool, a declarative tool, if we rerun it, the tool knows that there's no work to do. Now, let's just prove that it's not just a silly tool running a create table statement, and let's make some more interesting change. So here we are adding a column named password, and we are adding a constraint that the password will be at least 8 characters long, so our users do not use a password that are too short. We can now apply this, and we can see now that Atlas is calculating an alter table statement to add the constraint and add the column to our database. After we run this, this column is created along with the constraint. Okay, this is not what I want to show you. Okay, so in short, how does Atlas work? It connects to the database to inspect the current schema. It uses something called schema loader. You can provide the desired state of the database in many, many ways. As we've shown, we can use this HCL language to describe the schema. Atlas can even read directly from your ORM the application data model. So if you have developers that don't even want to think about the schema, you can just inspect it from their application code. Atlas then calculates the diff. It turns this diff into an execution plan. As we said, the order really matters, so Atlas must use algorithms like topological sort, if you remember your algorithms class from university, to make sure that the order and the dependencies are all set. And finally, it applies it on the database. Beautiful, right? We thought that we have changed the world and figured out the new way of doing things. So we didn't do, I'll share a story with you. We didn't do any marketing for Atlas. It was just an open source tool on GitHub. But as cool things do, it somehow arrived on Hacker News. So we woke up some Saturday to 5,000 comments on Hacker News that we need to deal with. Some of them were very positive, very cool. And some of them, on the orange side, not everybody has a positive sentiment. So I want to share with you some of criticism. So this person, Redact207, said, I'll never be comfortable with any tool that automatically generates schema changes, as I'm just never sure at what point it decides to delete parts of my production database. Scary, right? Would you let a declarative tool manage your production database? I think it's something that you should think about and reflect on, right? So we take this question very, very seriously, which is why we build a company around it, because we think it's actually not a trivial question. So I don't know who you are, Redact207, maybe you're here in the crowd. We take this question very seriously, which is the topic of the second half of my talk. What strategies can we employ to make it so that we can enjoy all the benefits of declarative workflows without suffering the risk and even improving on the current state of the art? So, going back to our navigation metaphor, in Israel we have a long road, a fast road called Road 6. Road 6 is a toll road. It's very nice to drive on it, but it costs money. So it's not always the optimal route to get from point A to point B, right? Depending on your time constraints and your budget, you may want to plan a way from A to B that goes through Road 6 or does not. And to apply to our metaphor, when you are making a schema change, there are often multiple ways to get from the current state of the database to the next. For example, if you change the name of a column from A to B, one way to get to the desired state is to drop A and create B, which is probably not what you would like. So what we need is similar to our navigation software that allows us to select to avoid toll roads. We need a way to feed policy into planning changes so that we don't get unintended results. Because schema changes are risky, if you're not careful, you can end up introducing destructive changes, deleting data, breaking changes, breaking the contract between your application and your database. In Postgres, you can lock your database for long periods of time if you don't know what you're doing. So we need strategies to mitigate this risk while maintaining the benefits. I will show 3 of them today and kind of introduce you to Atlas along the way. Okay, the first one we call automatic migration planning. So how it works, you can still work with Atlas in the classical way that you have a migration directory, right? You have files doing the changes. But in this case, the changes will not be planned by a human, but will be automatically planned by Atlas for you. So you still provide the desired state, but now the current state is not your real production database any state, but we take an empty database, we replay all the migrations, and then we calculate a diff between the last revision of the database and what we want it to be. And the output is a new migration script. We'll show a demo of this in a moment. Why do some teams prefer this? One, the changes are checked into Git, so they are reviewed during code review. If they are reviewed by humans, they can also be reviewed by machines during continuous integration. And some teams deploy to environments that they don't have a lot of control in. Some of them are not even connected to the internet, right? So we cannot be there to approve the plan when we are running a deployment. So we need to do this stuff in a pre-computed way. Let's show a quick demo of this, since our first one, it worked very well. If you look in my directory structure, you will notice I have a migration directory containing one SQL file to create the initial table that we had. And what I want to do is show you another Atlas command called Atlas migrate diff that is going to plan a migration from this state of the database to the next one. So you see we created a new file, and this file contains the same new column and constraint that we added before. Okay? Now let's do something a bit more risky and interesting, maybe. Let's now comment out this table T1, right? So now this is a dangerous change that we probably want to prevent, or at least to have someone approve it specifically, because now the migration is, if we calculate it, is to drop table T1. Okay, so how can we prevent these things from, slipping through accidentally in code review? So Atlas has another command called Atlas migrate lint. Okay, and lint is maybe understating what it does. It's a tool for doing something like static code analysis for schema changes. So we actually build a graph from the current and the desired state, and we have a really good semantic representation of the change. So we're able to analyze it on a deep level. For example, let's run this. It will open up our cloud UI. You can do this in the terminal just for presentation. It's much nicer to look at it this way. Okay, and you will see that what Atlas does, it replays the migrations on a empty database to make sure that the SQL is semantically correct and is going to work. And then it starts to analyze the different changes and give us some insights on this change. So for example, did you know that adding a non-nullable varchar column in MySQL implicitly set, without a default value, implicitly set the default to an empty string? So many developers do not know this. It may have significance in your application. And most importantly, Atlas, the CI, Atlas lint detected a destructive change. Now you can connect this to your CI pipeline and make sure that developers do not accidentally drop resources, which is our concern from before. The next thing I want to discuss is something that we call diff policies. Diff policies mean that we give Atlas an additional input, except the current and desired state, and we specify some rules about how the change must be calculated. Okay, so the two major examples that people seem to care about is, one, to disallow destructive changes, so that the drop table statement will not even be calculated. And the second one is that we can say to Atlas, always create the indexes concurrently. In Postgres, it means that the index creation happens asynchronously from the command that you run, and it can have a lower performance implication on the system. And the benefits are, one, you can avoid types of changes that you do not want. For example, some databases do not support creation of foreign keys at all. And you want to instruct Atlas to not even try. Right? The second thing is to be able to rewrite the plan in an intelligent way that fits your constraints and risk in the project. So we can show a quick demo of this. Let's reset this change. And what we're going to do, Atlas has this configuration file called Atlas HCL, and we're going to provide it with a diff policy. Okay? Now, again, we are going to drop the T1 table. Let's use a schema apply for this. Schema apply. And we can show that despite there being a change, Atlas shows that there's no work to do, because we provide it with policy that says you're not allowed to plan changes that include dropping a table or dropping a column, and so on. So this is how we can, another way in which we can avoid toll roads. How much time do we have? 6 minutes, perfect. The last bit I want to talk about, which is a bit more about the future, well, the present and the future, and it is something around how we think schema changes can be integrated into Kubernetes. So Kubernetes is famous for being really great for managing stateless resources, right? In the early KubeCons, the discussion was like, don't get into stateful sets and stateful resources unless you really know what you're doing, because the API is not really great and it's more difficult, right? But for stateless stuff, it's really Wonderful. Now, the way that the Kubernetes ecosystem overcome this challenge of using a declarative API for managing a stateful resource is something called the operator pattern. With the operator pattern, we extend the Kubernetes API to have new custom resources called CRDs. And then we build something called a controller, which is a piece of software that lives in your Kubernetes cluster and knows how to reconcile the specific type of resources. For example, you have operators for managing specific databases. And when you are changing something about a database instance, sometimes the strategy to make the change is to maybe take some snapshot, maybe to replicate the database and try it on the side, maybe to apply some heuristics and validations that are specific to this database, because it's tries to answer the question, if we had an operator, right, we had the fastest and best DBA in the world, how would they apply this change? And we take this knowledge and try to codify it into software. And this is the operator pattern. So a few months ago, we released the Atlas Kubernetes operator. And the Atlas Kubernetes operator basically extends Kubernetes to know about database schemas. So if you have, we have the Atlas schema resource, which you provide to it the desired state of your database. It has a much wider API, but stay with me just for getting the point across. The operator is sitting in your cluster. Whenever this custom resource changes, this triggers the same reconciliation loop that we show in the CLI. So it connects to the database, it inspects the current state, and it plans a change and applies it. Okay, so you basically can connect these changes and connect them to your Argo CD workflows or to whatever CD tooling you're using. Now, if you have been listening so far, the same question applies, right? How do we make sure that now this Kubernetes operator doesn't nuke our database, right? Because what if we changed the desired schema, and one way to interpret this change is to delete our users table, which we do not want. So we baked into the Atlas schema custom resource policies, and currently we have two kinds. One is linting policies, and the other is diffing policies. Linting policies mean that if Atlas detects a specific kind of change, it will prevent the deployment, right? The custom resource will remain in this wait pending state, similar to if you deploy a container image that does not exist, right? Kubernetes will try to reconcile it, but it will never move to the point of actually making the change. And the second kind of policy that you can provide the operator is a diff policy, right? For example, always create the index concurrently, because this is how we do it on this heavy loaded database. So this is stuff that already exists, and you can use it in production today, and many organizations do. But I want to talk a bit about future work, because I think the way we are heading to as an industry is more abstraction and more automation of infrastructure stuff, right? This is our profession as a DevOps and systems engineer. So we see our goal as people building this advanced database management technology to think about more and more things that we can abstract away from what the perfect operator would do and to codify this into our software. So examples of things that we are currently working on. To make decisions based on the target database state. For example, if you change a column to add a unique constraint, it may work, it will always work on an empty database. It might work on your staging database, but it might fail in production, because if you have a column that was not unique before, it could have the same two values, right? So we can block, if we are connected to the database, we can make decisions based on that. We are working on stuff to run data migrations. Sometimes you want to rewrite data in your cluster to support multi-stage migrations and a more advanced migration strategies. I want to say one last thing about the secret reason why I became CTO of a dev tooling company. You may think it is to build awesome tools and to solve annoying infrastructure problem, but the real true reason is that I could come to conferences like this today and to hand out amazing swag and gear to fellow developers. This is the best use of our investors' money, as you know. So we have these limited editions Atlas in Spain t-shirts. We have a raffle for a very nice Star Wars Lego kit and a bunch of other fun stuff. So if you want to talk about databases, or if you just want this t-shirt, come and talk to us in the booth after. And I thank you very much for your time. It has been lovely to talk to you.
So the introduction of HCL is for checking the drift in the database schema and all. Mm-hmm. In one of the demo, you did changes to the migration files as well. Mm-hmm. So in future or present, can we eliminate the usage of migration files altogether, or it would stay?
Amazing question. And exactly our goal, the way we see the future, is that migration directory will only be necessary in places where you don't have network connectivity to the target database, and for teams that have like compliance reasons or whatever that they need to document this in Git. But we are really doubling down on the declarative flows, and we will let you, as we add more and more policy, right? Most changes don't even need to be approved. If you're just adding a column, if it passed code review, it's fine. But for more complex stuff, then we are adding more control for operators and for engineering leaders to kind of set the rules by which Atlas behaves. So definitely the idea is that you have this agent in the system that's just responsible for reconciling, the database state to where you want. One of the things we're building into Atlas Cloud is a schema monitoring product. So if you're managing lots of databases and you have an operations team that need to make sure that everything is in order, if you have lots of clients or multi-tenant architecture, sometimes, migrations succeed for one tenant and fail for the other. So with some of our customers, we are working on, giving you these operations tools to understand this drift and to reconcile it on the specific places you have issues.
So for now, it would be there, the migrations.
Yeah. I mean, we have users using full declarative flow with Terraform or with Kubernetes, and we have teams using both flavors, right? So it's your consideration what to choose. For example, today in the declarative flow, we don't have data migrations, right? So there is still some gaps.
Thank you.
Yes. Okay, anyone want to keep talking? We can talk in the hallway and in the booth. Thanks a lot.